Okay, for the third lesson on Pythagorean theorem, you're going to be seeing questions similar to this one. It is going to give you the hypotenuse this time. It's going to give you one of the legs, and what's missing is the other leg. So you're still going to be able to use our Pythagorean theorem, a squared plus b squared equals c squared. So that's the first thing you want to do when you're working on these problems as well. You're going to write down that Pythagorean theorem. You're then going to substitute the numbers for one of your legs. It doesn't matter if you substitute it in for the A or the B, but it just has to be one of the legs. And you're going to be substituting for the hypotenuse this time. So you're going to have C plugged in as a numerical value today. You're going to square the numerical values that you have, but here's the new piece. You're going to have to get the x squared by itself. Remember, you're missing one of the legs today. The legs are on the left side of the equation typically when you set that up. So you're going to have to think of this as being a locker problem, and you're going to have to subtract from both sides of the equation to get x squared by itself. Just like yesterday, you're going to take the square root of both sides to finish the problem, and if you do not get an exact answer, you will be rounding to the nearest tenth. So those are the steps. That's what you're going to do, and you're going to need some practice to get good at these. So here is exactly what you need to have down on your paper. Again, number one, you're going to write down your Pythagorean theorem, because you can use Pythagorean theorem when you're finding any missing side of a right triangle. We definitely have a right triangle. The unknown side, I'm going to use the variable x, and I'm going to put that in for the first leg, the a squared. I'm going to put my 8 in for the other leg, the b squared. And I'm going to use my 10. Remember, that's the longest side of the triangle. It's the hypotenuse. Your hypotenuse always, 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 always goes over here for c. So again, the formula was a squared plus b squared equals c squared. I am looking for one of my legs, so I have it plugged in as x squared plus 8 squared equals 10 squared. So far we've done step 1 in our notes and step 2. Now we need to make sure that we square the numbers that we do have. We know that 8 squared is 64. We know that 10 squared is 100. So what we end up with today is this equation that we need to solve. We're trying to solve for x, but before we can do that, we need to get the x squared term by itself. So remember, if you have a locker problem, your locker is where your equal sign is, and you will need to move this number to the opposite side. We want x squared alone on the side by itself, and we want to have our numerical value on this side. So in this final step, we have our x squared equal to 36. If you remember from yesterday, if you're trying to get rid of the squaring, you're going to take the square root of both sides. So make sure you're showing this last step, because that's critical. That needs to be on your paper. Square root of 36 is 6. So we have an answer that is 6 centimeters that would finish this triangle. If you remember, we talked about the 3, 4, 5 right triangle the other day. All right, that's the most popular right triangle that there is, really, a 3, 4, 5 right triangle. This is kind of like a dilated version. If we double the size of our 345, it turns into a 6, 8, 10. So that's another reason why this works out to have such nice numbers. 6, 8, 10, and 3, 4, 5, they're kind of like cousins. Alright, next example on your note sheet. I would like you to draw in the right angle up in the top corner. We're not used to seeing triangles this way. Usually we see that right angle down in the bottom corner. So sometimes turning your paper is very helpful, because you can see, hey, this is a leg, but so is this. Alright, these are going to be your A and your B values. Across from the right angle, this longest side is actually your hypotenuse. So it's a good idea to label what you've been given in the very beginning before you try writing up your formula and substituting in, because sometimes looking like this, we mistake these for legs and we think that's the hypotenuse, and it really isn't. So a squared plus b squared equals c squared. Remember, you always write your formula down first. You're now going to plug in your legs. We have one leg that's missing, remember, so we can put that there, x squared. We have another leg that's 5, so we're going to put that in, 5 squared. And then we have this 17.5, and we're going to make sure we square that. That, remember, is your hypotenuse. It's the longest side of your right triangle. So we know this is x squared. We're going to leave that there for a minute. We know 5 squared is 25. We need to figure out what 17.5 is. And remember, if you're using your calculator to square 17.5, you can just hit the x squared button. Makes it a little bit easier. So we have 306.25. And then we have to do something else. And this new step that we know we need to do today is we need to isolate, or we need to get this x squared term by itself. So you will be subtracting 25 from both sides. We want that canceled out so that we can work on our last step, which is taking the square root. So I have 281.25. And again, at the very end, we know that x squared equals this value. So to undo, or to get rid of the x squared, we're going to take the square root. So square root of 281. Quick reminder, if you're taking the square root, you have to hit second, and then you have to hit the x squared button to get your symbol on there. So 281.25. We get about 16.77. And I think we decided earlier we're going to round to the nearest tenth. So this one is going to give us 16.8. And the units were meters, so always try to label your units. Last one is a word problem. And it starts out kind of strange. It talks about a ladder that's 17 feet long, and it's leaning against a wall. So I find it very helpful if you kind of draw a little picture. This is the wall of a house. If you take a ladder and you lean it against the wall, you're going to have that ladder look like this, where the rungs of the ladder kind of go up like that, so you can actually climb it safely. And again, you're leaning it up against the wall, and we do know that the ladder is 17 feet long, so we're going to label that part of the diagram. They then tell us the bottom of the ladder is 8 feet from the base of the wall. So the base of the wall, they're talking about the bottom of the wall. That means this part of the diagram is 8 feet. So even though they start out talking about a ladder and talking about a wall, it's really a Pythagorean theorem question because the ladder forms a right triangle with the wall. We have this measurement down here, which is one of your legs. We want to know how far up the wall is the top of the ladder. So we want to know what this distance is here, which would be another leg. And it turns out that the ladder forms the hypotenuse of the diagram for the right triangle. And we're assuming that the wall is perpendicular to the floor, that it's got a right angle down here at the bottom. So we can still use a squared plus b squared equals c squared. We can put our x in for one of our legs, we can put our 8 in for the other leg, and we have to reserve the 17 for our hypotenuse. So squaring the numbers that we have, we get 8 squared being 64. We get 17 squared being 289. We have a locker problem. Remember, if you're trying to solve for x, we've got to get x by itself, so you're subtracting. And then, let's see, 289 minus the 64, we get 225. 225, remember, we still have to square root both sides. X squared is 225. We want x. So notice in your work, you're going to have x at the very end of the problem. Square root of 225 should be 15. So how far up the wall is the top of the ladder? The top of the ladder is 15 feet up the wall.